Hello everyone. In this video, we will learn about stacks and queues using linked list and would try to understand its implementation. So, before starting, we should know what actually a stack is. So, a stack. A stack is an ordered collection of homogeneous data elements or objects. So, what is a homogeneous data element? Homogeneous means of the same type. So you can say that a stack is collection of objects which are of same type. A stack follows last in first out principle. What it means? It means that if any object is placed into the stack first, it would be the last one to come out. You can see like in this example. 1 is the first element to be entered into the stack. Now, if you want to try to take 1 out, you would need to try take out 5 first, then 4, then 3, then 2, and then 1. So, it means that the atom entered at the last will be the first one to go out. Now, the point from which the objects are inserted or removed is called as the top of stack, or you can say the first element of stack which you can be accessed by is the top of the stack. Now try to understand by this example. You are given an empty stack where no elements are placed initially. Now suppose you want to insert an element 1, then it would be placed at the bottom of stack, and the it would become the first element of the stack. Now you want to enter some other element. It would become the second element of stack and would be entered at top of one. Now if you want to enter any other element, suppose 2, it would become the third element at would be put at the top of stack. Now if you want to remove any element in place of inserting, it would be always removed from the top. So the last element entered, that is 3, would be deleted from the stack and only 2 elements would return. Now, as we know, our topic is implementation of stacks using linked list. So, before we implement it, let us try to understand the basics of a linked list. A linked list is a linear data structure which are connected via links. Now, in simple words, what a link is? Link is a collection of nodes where each node consists of data field and a reference or link in the form of other address to next node in the list. Now, it is very important to note that it is the address which enables us to access every element of the linked list through a pointer variable, whether it is stored in the next node or the previous node. Now, we would learn about presentation of stack using the linked list. The stack implementation, a stack contains a top pointer which is called as the head of stack, and it is the place from where the insertion and deletion operation happens. So, suppose it is the first element to be entered into the stack. Now, it contains a data and a pointer variable. This pointer variable points to the element placed above it. Then, its pointer would again point to the data placed above it, and so on till we reach the top. So the first node has a null, in the link field, and second link has the first node address in the link field, and so on till the last node address is in the top pointer. Now we would learn about operations on a stack. The first operation is push. This operation is performed to enter any element into the stack. The element entered will be stored one after another till the maximum size of the stack is reached. Now, once the stack is full, by saying full, uh, I want to mean that suppose the maximum size defined for this stack is 5. Now, if you try to enter the sixth element into the stack, it is not possible and is said to be as overflow condition. Now, what is the step to insert an element into the stack using linked list? So, suppose this is the representation of the stack where there is a head pointer which points to the top. It is the next element till the bottom element is found. Now, if we want to enter an element into the stack, it would be always at the top. So, what we do is break the link between top of the stack and the element below it and enter it to the top. Please note that head itself is not an element but only a reference variable. So what now we will try and understand the algorithm for inserting an element into a stack. So at first we would take the element which is to be entered as an input from the user. Now we would create a temporary node. The node will contain two fields which are data and the link. The link will link the node to the top. Now we create a temporary node using the malloc function and assign the data column with the item which is received from the user, and we link that node to the top and we update the top value as that node. Now our push function is completed and we have completed inserting an element into the stack. Pop. The pop operation is performed to remove an item from the stack. Suppose there are 5 elements into the stack and we want to remove them. Then we would use the pop operation and the element placed at the top of stack would be removed. As you can see, object 5 is removed and only 4 elements now remain in the stack, with object 4 becoming the new top of the stack. So what is the steps to remove an element from the stack? So we would at first check if the stack is empty. If the stack is empty, we cannot remove any element, as to remove any element it is necessary that at least one element is present. So we would show a stack underflow error. Now, if it is not empty, we would create a temporary node and set it to top. Now we would create another variable and copy the top element to this variable. Now we make top point to the next one, means the top would point to the second element from the top to the data. Now we would delete the temporary node and return the node. You can see in this algorithm we would create a temporary node and assign memory to it dynamically. top is empty, we would throw a stack under flow error. If not, we would assign the top to it. Now we will link the temporary node to the top and free the temporary variable. So now the second element would become the new top of the stack, deleting the first one. The next operation in our list is display. Display is the simple function which enables us to view all the elements of a stack. Currently, there are 4 elements in the stack, and if you implement display function, it would give you the elements in it, that is D, C, B, and A. Now we would see the algorithm for displaying the elements of a stack. We would at first again create a temporary variable and assign value to it using dynamic memory allocation. Now, if the top is empty, that means there is no element in the stack and we cannot print an element. So, it should throw an underflow condition, which is clearly mentioned here. And if not, if there is at least a single element in the stack, we would assign the temporary variable to top, and while temporary value is not null, we will print the data elements until the end. So all the elements in the stack would be printed one by one. There are some other helpful functions in stack as well, like is full and is empty function. Is full condition is used to check if the stack is full. Now, how would you check it? Suppose you have a stack of defined size. We called it as max size. Now, if the top equals to the max size, that means the stack is completely full up to the top and no more elements can be inserted. So, if top equals to max size, it returns true, else return false. True means the stack is full, else it means there is some space available for the new element to be entered. Is empty. Is empty function is used to check if a stack is empty or not. Now, how would we check it? If top is less than 1, what that means? We initialize the stack with stack 0. So no, so the maximum, so the minimum uh, index it can have is 0. Now if you try to go below it, that means it is empty. So it would throw an error called stack underflow. So if it is true, it means stack is empty. Or if it is false, it means there is at least one element present in the stack. Now we will try to understand the real life implementation of a stack and how it works. Suppose we want to enter some element into the stack. We use the push button and suppose we enter any random number, take as 38 in the stack. It would be entered into the stack, and since it is the first element, it would be the head or the top of the stack. Now we try to enter any other element. Now as you can see, it would go on and become the new top of the stack. Similarly, we add any other run. Now it will be entered to the top and become the new top of the stack. Now I will try to explain you the pop feature. We use the pop button. The top element of the stack would be deleted from the stack and would be removed. It is important to note that only the top element is removed and not any random element. We remove one other element, you would see the top is again delinked and removed from the stack, and the element below it becomes the top of the stack. Now, if we try to use the peak button, what it helps that it would return you the top element of stack, that is 38. Hope that you would be able to understand the concepts of push, pop, and peak. Thank you. Now, now we will try and learn about queues and its implementation using linked list. So, first of all, it is important to understand what is a queue. So, queue is a simple data structure in which elements are entered linearly, or you can say one by one, and it follows first in first out. What it actually means that if you enter an element into the queue first, it would be the first to come out of it. Suppose you can take real life example from queue standing in front of a ticket counter. So, if a person goes to buy the ticket first, he would be the first one to get it and come out of the queue, while the last person to enter the queue would be the last one to come out of it. So, it is very clear that queue has two ends, rear and front. From the rear part insertion, or you can tell the people can enter into the queue, or the front part where the people can get out of the queue, or you can say are deleted. So there are two ends in a queue which are named rear and front. Now we would try and understand the operations on a queue. So there are mainly four basic operations on a queue, that is enqueue, dequeue, display, and peek. Enqueue means to insert an element into the queue. Dequeue means to delete an element from the queue. Display means to print the elements present into the queue, while peek returns you the element present at the front of queue. So, if we try and to understand this diagram, initially we have an empty queue. Now, when we insert an element to it, it is inserted and from the rear part and gets a queue of size 1. Now, if we enter another element 24, it is entered to the queue from the rear side and the size of the queue becomes 2. Similarly, if you try to remove an element, it is removed from the front and the size of queue is decremented by 1. Similarly, if we use the display function, it will return us the element present in the queue, which you can see 24 and 36. Now, we will try to understand the algorithm for enqueue operations in a queue. So, as you know, enqueue function is used to insert an element into the queue. First of all, we would create a new node with a given value. That means we would take the element from the user and set the next of new node to null. If the rear part of queue is empty, that we will set rear as null. That means the queue is empty. So if it is empty, we would set the front node as new node and rear as new node. Okay. If it is not empty, then we will set rear nodes equal to new node and rear equal to new node. What it means you can understand from here. Suppose we create a new node and set its data equal to d, which is the element taken from the user. Now we will make its next as null. So if rear and front both are null, we will increment front and rear as new null. Else we would increment the rear pointer as new node. So it would enter a new node with the required data element into the queue. So it is how in-queue operations are performed. Now, if we take the real life example, or you can say its implementation, if we take an empty queue, both front and rear are initialized to -1. Now, when an element 7 is entered, when element 7 is entered, the real node is incremented. So now it becomes 0. Initially it was -1. Now if we try and enter another element, the rear node will again be incremented and will be set as 1. Similarly for -9 and so on. Every time you enter an element, a rear node would be incremented. Now, algorithm for dequeue operation, or you can say for deleting an element from the queue. Initially, we will check if the queue is empty. If the queue is empty, you cannot delete any element from the queue. As for deleting a new element, there should be at least one element in the queue. Now, if it is not empty, we will create a temporary node and set it to front. Then we would point the next operand to front and delete the temporary value. What it means that we would link the temporary node to the next operand and delete the temporary node. What it would do that the top, or you can say the last element of the queue would delete. Suppose there are two elements in this queue and we want to delete one of the elements. Actually, in the beginning, there was three elements in the queue, and when we run the queue operation, the last element from the queue is deleted. This element would be deleted from the front part of the queue. So the front would be incremented and it becomes -1. It becomes 1. Initially it was 0. Similarly, if you try to dequeue one more element, it would be incremented once more and would become 2. But since we will check the initial condition that was front equal to rear, if it is so, both front and rear would be pointed to -1. That means there are no more elements in the queue. Now we would see algorithm for display operation. What is basically display operation does is that it will return you all the elements in queue. At first, we would check if queue is empty or not. If it is empty, we cannot print any elements. So now, if it is not empty, we would create a temporary variable and access all the nodes present in the queue. As you can see, temp next is not equal to null. So, till the next of temporary pointer is not equal to null, we would access all the nodes and print the data element and it would return us all the elements of the queue. Peak operation. Peak is a very simple operation and it returns you the last element of the queue, or you can say the latest element which was entered into the queue. So, how you can get it? It is very simple. You just need to access where the front pointer is pointing. So, you just print Q front. It will return you the element which is entered at the very first to the queue. Full function is full function returns you the true or false. Generally, it is a boolean value which tells you if the queue is full or not. How would you check it? You just need to check the real point. If here, that means from the end, that means the end from which you enter the element is equal to the maximum size, then it is full. So no more elements can be entered because it has reached the maximum size. So the query is full, else they are not. Is null or is empty function. This function will tell you if the queue is empty or not. Now, how can you check it? It is again very simple. You just need to check the initial condition, which is rear and front both are pointing to the null memory space. That is minus 1. If both is equal to minus 1, Q is empty. And if they are not, you would return Q is not empty. It is Q rear is equal to Q front equal to minus 1. When this condition is satisfied, we say the queue is empty, else the queue is not empty. Thank you.